Okay, this is a video just basically showing you how to cycle your packs. Right now I'm going to do a balance charge, so I have my screen set on Lipo balance charge. I'm charging this pack at 30 amps. It's a 4S pack. This pack is pretty much charged, so the only thing it should be doing is topping the cells off. And then, so once I hit the start button, I'm going to go over to my other screen and show you how LogView is plotting it on the screen. So let me go ahead and start this up now. I'm just press and hold the start button. Checking the battery. Alright, it should be ramping up the current. Alright, so now I'm going to go over here. But there's a little line up here where it's plotting the voltages, and so this is the plot outline for it. Also, there's some other information over here off to the side, basically showing you the input voltage 12.85 volts, output voltage 16.87, the current is 3.42 amps, and dropping since it's fully charged. The capacity that it's put in so far is 128 milliamp hours. The power, it shows how much wattage is putting into the pack, and it's about 50 watts. It shows what mode it is. It's in charging mode, and the internal temperature is 30 C, and then it gives all the cell voltages for cell 1, 2, 3, 4. 5 and 6 aren't populated because I don't have a 6S pack. And down here there's a little menu that shows you in a visual sense which each pack is sitting at on a graph. And so all of my packs are pretty much at like 4.2 volts. Some are sitting at 4.21, and it shows the differential like 0.005 cell deviation. I'm not going to show you like the whole balancing phase. Right now it's just balancing the packs to get them as close as possible, to get all the cells as close as possible to each other. But it plots out like this, and then you'll eventually end up with a full graph that shows you the charging curve of the battery. To cycle your battery packs, what you would normally do is you connect your battery to your charger. Make sure your main leads are connected and your balance leads are connected, so the LogView can plot it out, all your cell voltages out on the screen. You then, when your charger comes up, you have like the program select screen. Make sure you select lithium battery. Then you go to the where it says cycle, Lipo cycle, and then it'll have like cycle 1 or whatever. To do a full cycle on the Lipo, like to really get the true capacity of it, make sure it's flashing Lipo up here. And to make sure you set this correctly, you have to go to your other charge screen and make sure the right voltage is set and everything. I personally set mine to 4.21 to get a full thorough charge. And then you can change certain aspects, like how many times you want to cycle the pack, what voltage you want it to charge to, and what voltage you want it to discharge to get a full amp hour capacity of a pack. You want to charge to 4.2 volts and your discharge at 3.0 volts. The charger will automatically sense and stop and start the charging for you. And then over in LogView, it'll sit there and it'll log all the information. On a typical 5 amp hour pack, well, I have a 4S. When I was cycling my packs, I had 4S 5 amp hour packs, and so it took me basically an hour to discharge that pack. Your time may vary, maybe a little bit more, maybe a little bit less. But I'm just basically going to go ahead and start the discharge up. And if you tap it once, it'll select Lipo or the different chemistries, and make sure when you cycle in Hobby King Lipo or Flight Max or whatever packs that you have. Make sure you know the chemistry, but in my case I have Turn-G packs, so they're Lipo. You hit it again, it'll change the cycle count. I really want this pack cycle once, so what it will do is it will charge the pack and it will discharge the pack. And so and that's what one cycle does. So we want to leave it at one cycle, because at the end of the discharge you want to see how the cell reacts to see if the voltage bounces back, you know, and if you have the cycle set at more than 2, once it finally discharges, it'll automatically start recharging again, and that's not good for any type of diagnostic, because like once you discharge that cell to 3 volts, it's supposed to rebound back to like 3.2, 3.3 within like 2 or 3 minutes, and that can normally tell if it's a good cell or not. So once your lowest cell, once your rent cell or your lowest capacity cell is 3 volts, the charger will stop. You can then look at it in LogView, and then you can look at the voltage creep back up to see if it rebounds like it's supposed to. This flashing on the screen, it shows you what your charging voltage and your discharge voltage is. It shows basically you want the charger to charge up to 4.2 volts a cell and discharge down to 3 volts a cell. And you can change that by hitting again, and you see 4.2 is flashing. We're going to leave that the same. Discharge is flashing at 3.0 volts or 3 volts a cell. If you want to be conservative, you can stop it at 3.1, 3.2, 3.3, but to see the full capacity of a Lipo pack and all its cells, you want to take it down to at least 3 volts to see, you know, see everything that is that this pack has to show, you know, because stopping early can, you know, it can still hide cells that have low capacity. If you stop at like 3.6 volts or 3.7 volts, yeah, it's a cell that's mostly discharged, but if you run your packs like that, you'll never know what your packs are fully capable of. And you know, you never should take a Lipo to the grave every single cycle. We're only going to do this just to check the capacity, and I think it's totally, you know, a justified cycle to do this. But you know, take it at 3 volts a cell while cycling your packs and discharging them to try to find capacity. But when you actually put your packs in service, you know, you want to stop a little bit earlier, like around 3.4, 3.5 volts a cell, just to make sure you're protecting your pack. And even still, that's a full discharge, so you know, you would like to stay above 80% of the capacity of your pack. So those are just some rules of thumb for Lipo. Only do deep discharges when you have to. Alright, so we're going to keep going with everything. Alright, everything is set on the menu. Alright, so we're just going to press and hold, and it'll actually start the discharge cycle. On my iCharger, I can discharge up to 80 watts. Okay, right now I have the Lipo in discharge mode, and you'll hear the fan spin up to cool the charger down. Right now it's discharging at 4.7 amps. It shows you the amps, how many amp hours currently discharged, what the voltage is, and how long it's taking. And then so you'll go over here to LogView, and so we get my LogView back in range. And so right now you'll see it, you know, ticking across the screen, and you'll eventually start, once the graph starts getting enough data, you'll start seeing it, you know, slope down to where it gives you the discharge curve of the battery. Again, it's giving you all the information over here for the cell levels, and then there's the graph down there. The graph actually is a good indicator. You can almost tell part of the way through the discharge, which cell is performing well or which aren't, and which one you need to keep an eye on during the discharge. Now, like I said, as long as you have your iCharger set up, it'll like I said, it'll automatically charge the cells up to 4.2 volts, and then it'll automatically discharge the cells to 3 volts. And this whole time, this is logging your data, and this can run in the background. You can still do other stuff. I mean, all you have to do is just minimize this, and you can continue on doing other programs, going to websites or whatever. You know, it's still logging in the background. All I got to do is call it up down here. Where's it? LogView. Go back over here, and like I said, it's still plotting. So, and that basically shows you how to use LogView to basically check your packs and everything to make sure they're up to snuff, or you know, they're on par. Another thing that you can look at, LogView has a different view where, you know, it actually shows you table data on, you know, what the current was, what the voltage was. It gives you all the information that you need in the big table that you can scroll through. And if you're cycling multiple packs, it even has a drop down menu of your last few charge and discharge cycles, to where, oh, you know, I charged the pack, my last pack, I need to know the data for it. So let me just go back to it, and it'll give you all the historical data of that specific pack, and you can plot it out in a graph. So like I said, right now I don't have enough graph data to really show anything, because I'm just doing a demo video. But that's pretty much how you use LogView. You're gonna have to play around in LogView a little bit to get everything to display the way you want. But that's pretty much how everything works. Now I'm gonna show you what a good plot and things to look out for on a discharge plot. Okay, what we have here is what a weak pack would look like on the discharge graph in LogView. This is one of my 4S packs. You'll see like 4 different color lines basically showing what the voltage was at each of each cell. But at the beginning, you already see one that's already significantly lower than the others, and if you plot it all the way down, it still always stay lower than the others. And right when you get at the end, you'll see the Lipo cliff. You know, this is where the voltage drops off extremely, and like everybody says, you know, you need to stop before this cliff, because whatever is available after this, there's no real capacity after this. There may be 0.2, 0.3 amp hours left in this last bit, and it drops down so fast that you can like ruin a pack if you allow the cell voltage to drop too low. Again, but again, the iCharger was controlling this discharge, so you know, it discharged it from 4.2 volts a cell all the way down to 3 volts a cell, 3 volts a cell, or until the lowest capacity cell hits 3 volts. Now you obviously see there's 3 cells in this pack that obviously still could have kept going for some time. This pack right here, it was a 5 amp hour Turnigy pack. It was pack 13 out of the 24 that I have, and this one delivered 4.762 amp hours. So, you know, there were still 0.3, 0.4 amp hours left out of this, but this cell didn't quite make it. It only gave 4.7 amp hours, while the other cells could have kept discharging. And like I said, one of the key signs to look for is when the cell voltage sits lower than the others during the whole discharge graph, and when it falls off extremely early. I have another cell that I can show you that will pretty much do the same thing. Let's see. Alright, here's another one that this cell was able to hide for a good part of the discharge, and I'm not sure if you can see it, but you know, it stays pretty tight for most of the discharge, but as it gets towards the end, you start seeing it kind of separate from the other packs, and then it falls off extremely early and extremely abruptly before the other ones even begin to get it's not even a quarter away in their lipo fall. So, you know, this was another runt pack. This was pack 7, and it was cell number 4 that was bad, and it gave 4.785 amp hours. Now, you know, these Turnigy packs, they are known to, they're supposed to be known for giving their full capacity at the claimed C rate. So this was at 1C, and these are 30C cells. So it wasn't able to even give anywhere near its full capacity at abysmal C rate. So I mean, there's nothing I can do but go ahead and disqualify this pack, because this pack wouldn't be on par to operate and perform its task at its full capacity. I mean, yeah, I could have hit it with other cells, but this will always be a pack that you have to keep an eye on, and that low cell may eventually end up going bad, and it will start either dropping off a little early. Now, don't get me wrong, there are some times where you may have a dud cell that will perk up, you know, and actually I've had, I think this is the pack that I sold that it originally gave 4.5 amp hours, and then I cycled it again and it gave 4.785, so it did gain capacity after 2 cycles. But if right out the gate it's already delivering low capacity and you have to cycle it a few times to get it in line with the others, then, you know, I'd rather have all of my cells come out the factory at the same level and doing what they're supposed to do, giving me the full capacity and everything, you know, and not be trying to coax it with several discharge cycles to try to get it to do full capacity. I end up selling these 2 packs at a loss. The packs were $23 a piece. I end up selling them for I think they were like $12 a piece. I end up selling them for on the forum as like not scrap packs. I mean, you can still get the good sales and everything out of them, but they're just not worth saving around and having them in your full pack. Now, some of the discharge data that I did record off of each cell, I record data off of all of my packs, and then I label the packs to let me know in the future what the weak cell was, and which ones that I need to keep an eye on. But the thing is, I qualify all my packs to give full capacity, so I'm not worried about any of these cells. But on the packs, it tells me what pack number it was, and like this one is pack 23, 24, 25, 26. It gives me what the lowest cell was, what the cell voltage was at 5 amp hours, and the total amp hours that it gave out at 3 volts a cell on the lowest cell. I went through 24 of these packs, and it does take some time, but it's worth it to check these packs and cycle them for, you know, 2 or 3 days, and then group them by what the capacity is. Like when you group your packs together, you don't want to have too many packs with the weak cell. Let's say if you had 4 packs and they all had cell number 3 that was weak, you really don't want that. Like in this one, I have pack 4, pack 16, pack 8, and pack 14 all grouped together. And on pack 4, cell 3 was the lowest. On pack 16, cell 1 was the lowest. Pack 8, cell 3 was the lowest. And pack 14 cell 4 was loaded. So this is a decent mix where you don't have all your bad cells grouped up in, you know, one cell bank. And so you, instead of, you know, having an extremely weak cell on a certain cell group, you spread it out across the whole pack. But when I cycled these packs give, you know, way more than their capacity. They gave like 20.5, 20.6 amp hours, so they're giving a little bit more than their rated capacity. Just going through one more bank that I went through. This one has 4 packs in it. Then I have pack 5, pack 3, pack 2, pack 1 grouped together. And this shows you how I spread the weak cells across the whole pack. Like pack 5 has cell 4 that's weak. Pack 3 has cell 1 that's weak. Pack 2 has cell 3 that's weak. And pack 1 has cell 2 that's weak. And by weak cell, it's not that it wasn't given capacity. It's just that's the cell that hit the lipo cliff the quickest. And so it's not that I have to keep an eye on it, because it did qualify and did give me full capacity. But I label it so just in case I did have some type of problem, that would be the first cell that I would check to see if everything was working okay. And I think that's pretty much it. On the Turnigy pack, you can expect anywhere to where it will barely get 5 amp hours, and some of them give way more than that. Like I have 5.052 being the lowest capacity pack in this group, but I have one that's at 5.2, so there's a 0.2 amp hour difference in those packs. So you will have some packs that are very, very strong, and then you will have some that's not so strong, but they still pass the capacity test. So right now I'm at is discharging at 40 discharge, 1.2 amp hours out the cell. The pack voltage is 16.4. It's been 15 minutes. And right now it's showing the data so far. Since I closed LogView out, it erased the plot graphs. But right now it's showing, you know, 4.1 volts a cell, 4.12. So this pack is doing good so far. But yeah, this pretty much goes over everything, how to check your cells with LogView.